So this is a demo of deploying specific artifacts from a CollabNet TeamForge based system to a set of Docker containers that are managed by by a project called Openshift Origin. So we have made a DevOps solution that will use CollabNet TeamForge as a source. CollabNet TeamForge, as you know, is an application lifecycle management system which has got a set of projects. The projects could have version like various version control systems, and we would use Git for this demonstration. So the specific source code that's committed to a Git repository will be taken from there and deployed onto specific Docker containers that are managed by OpenShift Origin and a project called Google's project called Kubernetes. And we have some custom software that actually bridges all of these things, so that when you commit to a TeamForge project, it automatically gets deployed onto containers and are managed. You also get standard things like you can scale down the number of entries, you can scale up or down the number of entries, you can cancel, you can roll back a deployment. We'll see how much we can get in this demo, but we can do it afterwards also. And for the purposes of this demo, I'm actually using a CentOS machines for all of them, and I'm actually running it on my laptop. So I have a Vagrant machine that runs 3 specific instances. I have 1 master node and I have 2 slave nodes. The 2 slave nodes are the ones where all the containers will be running, and the master node is just like orchestrating the whole like solution. So let's start with a standard TeamForge edition. I have a TeamForge 8.0 edition, and I'm just gonna log in as a user. I've actually set up a project called Test1, and which is just a standard project. It's got tracker, source code, all the standard things that you would see in a TeamForge project. And on the source code repository, I've got a couple of repositories, Git repositories. Apologize for the names, but one of them is a Ruby project and one of them is a PHP project. I wanted to show 2 different examples so you can see what kinds of things can be deployed. Out of the box, there is support for Node.js, PHP, Python, Ruby, Java, or anything that's got like Maven projects, anything that's got standard things like a gem file for Ruby, package.json for Node.js files, a composer file for PHP, and a pom.xml for Java projects. This is the predefined standard, but if there is something else, we can work around it. We can actually create images and we can start from there. So let's look at what's inside one of these standard repositories. So if I look into the test1 project, it's basically a Ruby project. It's a Ruby hello world kind of thing. It's basically a key value like application. So it's got a gem file which manages all the dependencies, and ultimately what it does is it's got a screen where you can put some entries into a dictionary and take values from a dictionary, remove values from dictionary. So it's an app that involves Ruby. It's a Sinatra based app, and it connects with MySQL. So the purpose of this demonstration is to have 2 separate containers. So it's working on the concept of microservices. So you have one microservice that's running MySQL and another microservice that's running Ruby, and we'll show you how it connects and then works with each other. The second one is actually a PHP project. It's a framework called Silex. Silex is another micro framework, and it works very, there's a very simple index.php which basically says hello world, something like that. So these are the 2 specific projects that we have. Let me just check out these things on my machine, and then we could get forward from there. Okay, let me just delete the repository and start off from fresh. Okay, so I've checked out the first project. I'll check out the PHP project as well. Okay, so this is my project which got a Ruby project. So as you can see from a gem file, it's a Sinatra based project. It's got dependencies and so on. And for the purposes of this demo, what we will do is when we actually change some code and commit it into this one, it'll get deployed onto a target environment. So what I have also done is I have set up the project using that OpenShift, and OpenShift is a Red Hat project which allows you to orchestrate the whole solution. Ultimately, this will be a single sign-on. It'll be a single sign-on from TeamForge. So when you log into TeamForge, you'll probably have a button there that will take you to this login rather than you logging in separately to the system. I haven't done the single sign-on yet. It's a custom plugin that we have to work on. So so what it'll basically do is you will see a project for every TeamForge project that you will have a project inside OpenShift Origin, and the project would basically have whatever things that you're trying to deploy into this. So because I've already set it up for this project, this involves a database, which is basically a MySQL database for the Ruby Hello World program, and there is a front-end service that it also runs. So I have managed to set up two replicas of it. So if one of them goes down, OpenShift and Kubernetes will take care of bringing up another one, or if you wanted to bring up another one, you can also scale this up. So I've got two of the containers that are also running the same project, and they both connect to the same MySQL instance. And the third one is a PHP project, which is basically also running two specific instances, and I can change it. So you can see some of the things that are obvious here, like the source code for that is the one that we pulled out. The test1 project is a Ruby project, and the test2 project is a PHP project, and these are the ones that I just created before the demo. So these are the various builds and so on, but I'll show you how you can configure these things from TeamForge. But then this is where ultimately it actually gets deployed, and we'll be able to see the results of it when we commit the whole project. So let me just change something in the up file. So let me just say on let's try 5, 15, whatever. So I'm just going to add this file, commit it, and then push it. So once I push it, what happens is it'll actually trigger a build on the, like OpenShift using the bridge that we have this thing written. So it takes the source code from CollabNet TeamForge, and then it deploys it onto one of the containers. So it'll basically deploy into one of the two containers first, and then it'll also deploy to the other one. So ultimately it actually lands on all the replicas that we have. The entire idea of having a replica is if you want to kill one of them, it'll automatically start it up. You don't have to manage anything, it just is managed automatically for you. So let me just push it. So I've pushed the change, and what I can see is you can actually see there's the build 4 is actually running, which is the new build. So the build that was existing was build 3, and build 4 is actually running. The build 4 started running because we just made a change. So if I wanted to look at the builds, I could see that Ruby sample build 4 is actually running. It's been running for 20 seconds, which is the time that we did the change. If you really wanted to see what's happening, you could get into the shell and see it. So for example, if you wanted to see the builds, I'm trying to see what's the best way to get a UI for this one so you can see what's going on. So if so the build 4 is what is actually running. So as you can see, everything has been completed, cancelled or failed, and I have the fourth one that's actually running. So I can do a follow, and as you can see, the logs is basically pushing everything. So it's installing the source. It's basically taking a bundle install from the gem file. It's installing all your dependencies, and it's actually pushed the changes. So now the build is actually complete. Let me see if it's actually pushed over. So as you can see, it's actually pushed it to both of them. What I'm going to do right now is, because the builds are actually done, and the builds are in fact running on two separate boxes. So it's actually, as you can see, one of them is pending. So the two of them are actually done now. So like both the replicas are done now. The problem with this is that these two are internal IP addresses, so you wouldn't really know which one to connect, because the general idea of like completely orchestrating something using OpenShift and Kubernetes is that you don't really have to worry about which node something is running on. You have a load balancer IP that you can connect to, and the load balancer knows what are all the instances that are running, and it will automatically connect to one of them. So as you can see, these two addresses are 10.1 addresses, which I won't be able to resolve from my actual host machine. So I have a load balancer that is automatically configured, and the load balancer IP address will tell you how to connect to the individual addresses. So they're called services, and I have a service called front end, which is the one that's connecting. It's got an IP address of 172.30.188 and 48. So what I'm going to do is I'm actually going to instead of connecting to it, I've basically done a local port forward. So basically local port port forwarded 172.30.188.48, and it's running on port 5432 onto a local port called 9999. So let me connect to localhost 9999 and see what it gives us. So as you can see, this is the change that we made. So you can see like it's a welcome app, and the demo on August 25, 2015 is a change that I made. If I make another change, it will automatically get deployed and so on. So this is a simple way of how you can deploy something. You can start something from Collabnet Teamforge and get it deployed onto a standard instance. So uh, let's just add a key value here. Um, so I can just do a put. It's basically created. If I delete it and do a get, basically gets me the value. So if you really wanted to get into the box to see what's going on, the best way to do that is uh, so just to give you a background of how this whole thing runs. These containers are running in something called as a pod. A pod is nothing but a collection of containers. So if you have multiple services that you wanted to run, you could actually put them into a single pod, and pod is nothing but just a collection of containers. So these are all the pods that are actually running. So you can see there is one database pod, there are two front-end pods, there are some PHP pods, and so on and so forth. So if I wanted to get into this pod to see what's going on, I can just do just so if I do OC get pods, it gets me that. TOSI is a standard acronym for the OpenShift client. As I said before, we're actually trying to get a lot of these things onto the UI, the OpenShift UI. But for now, command line is the way to go. You can do a remote shell into that one, and it'll actually take you into a shell that's inside the container. So if I wanted to log into MySQL for this one, um, so if I show databases, my database is called root, and if I do key pairs, it's basically the one that I have. So I can keep adding that and put it into this one, and I would have that. So this is basically a way into getting into this containers. But as you can see, this is a little bit complex. You have to know a little bit about the terminologies, like you have to know what the pod is, you have to know what the pod ID is, you should know the OpenShift client. So there are a few complexities involved around it. What I'm working on and what I'm going to show you as part of the PHP demo is a way by which you can get a UI into this and you can see what it is. So that instead of like logging in through a shell and doing all this stuff, you can just like do it from the web browser. So let's go back to the to my shell. Sorry. So I'm actually going to show this now into the other project. So I have the PHP project that I have. It's got a simple index.php app. So I'm just going to say hello demo world. Okay, I'm just going to add it as before and push it. So now it actually does the same thing. So if I look at it, I should get another build on my console. I can see build 4 is running, as you can see here. So if I go back to my builds, I have build 4 that's actually running. And if I wanted to see as before what's happening on my build, I can do get builds. Build says PHP sample build 4 is running. So if I do a build logs, it'll tell me whatever is happening. So this is basically the deployment of my PHP app. So it's based on a composer file. A composer file is very similar to how a gem file works. You specify all the dependencies and it downloads it. So uh, it basically knows it has to pull it and run it. So it's installing the dependencies right now. Takes a little bit of time because it has to download stuff from the internet. So okay, yep, there it goes. I actually have 2 instances of the logs printing because I put it at a much verbose log level. So this one from the std out and one from the logs. So apologize for that. But So while it's actually running, I could tell you what it does basically. So this is basically doing a hello, but I also have a window into the whole shell. So as before, instead of doing a remote shell onto the container, I have a web app that I can log in and I'll be able to see. It's a little bit insecure because you can log into the shell and do certain things, but it's completely optional. I mean, if you wanted to do it instead of going into a remote shell because developers might not be comfortable with it, this gives you a window by which you can do that thing. So it's almost done, so it's completed. It's pushing it to a local registry so that it's available to multiple apps. uh, let's see what happens. Takes a little bit of time because this is a much heavier app than, because of the dependencies that we have, than the Ruby one. So takes a little bit of time to push between. I mean, like as I said before, I have one master and two slaves. So this is basically pushing the image onto a central registry that I am maintaining, and from the registry to go to the individual machines. So if you have like any number of replicas, it will automatically be able to go to those replicas and push all the images over there. So this should finish anytime. It should finish. Okay. Uh, while we wait for that to finish, let's actually see what's going on the overall side of things here. So let's see if there is something that's getting changed here. It still says it's actually running, and then it should kind of like shift each of them to pending state and then like deploy it to that state. So still trying to push. So, it obviously again depends on the size of your images, because if the images are going to be bigger, then it automatically means it takes more time to push from the master node to the registry onto the slave nodes. See how that goes. So, yep, that's successfully pushed finally. So now you would see that it'll actually change to a deployed status from each and every one of them. So every one of these nodes will be pushed for a change, and then it'll get deployed to each and every one of those nodes. Um, yep, that's pulling it, and the second one should also be pulled and deployed right now. So I should have a second node that comes up because I had set up two pods, two specific replicas that have to be running. So the second one should just be, so that's pending, scheduled, and that should just be running. It's pulling it and running. Okay, so now I have two separate other like IP addresses internal. So it says it's 10.1.123 and 10.1.0.28, which basically are the ones that are running. So now if I wanted to see what's going on for this, like if I wanted to see it again, I have a load balancer that's been configured, and the load balancer is 172.30.221.204. I have already connected to that one, so I've already done another local port forward for this. We could obviously have an external IP address that resolves to this one, but because I'm running everything on a laptop, I don't have the provision of doing that. I could have a DNS masquerade as well, so I can have a Vagrant DNS mask that will be able to resolve all those IP addresses, but for the purposes of this demo, I didn't actually manage to do it. So if I do a 9998, you'd see it's a hello demo world from Silex on August 25th. This is exactly the same as the other one, but the interesting part of this demo is what happens if you really wanted to see what's going on inside the box. So I have another service called GoTTY, which is basically a window into a shell, and I put forwarded it to like port 9997 on this one. So if I go into localhost 9997, I'd actually be able to see, or maybe not. Actually, I should change the IP address because it's different. Um, so if you look at the pods that are here, so it's PHP front-end pod. It's running on 10.1.123. So now if I do 9997, I actually get a shell into my whole box. So this is my PHP app that I had. So the index.html that basically says hello world from demo. It's not advised to change things here because this is just a window, and ideally I don't want to give like a right window into this one because people could, I mean, I have access to the whole box right now, so I could kind of remove stuff here, but I just demonstrated for the purposes of it. I could make this window just a read only window so you can just see it, not able to interact with it, but uh, again, for the purposes of this demo, this is just so you have the same file and you have a window into the whole app, and you'd be able to see everything in here. So uh, that basically concludes the whole demo. So as the entire idea of this is that you have a TeamForge project where you have various like commits that are happening. Obviously, you can do the standard things like you can have a tracker where you have like artifacts. You can associate those trackers to TeamForge, and you would have a button here that will ideally take you to this window. So each project in TeamForge connects to OpenShift origin project, and within like OpenShift origin, you could see. So this is my project that I have. So if I go back to my window, so you would see something like this, and we wouldn't have, because I am like an admin right now, I have access to do various things, but you would see this window where you can see the project, and the project would have various entries here, like builds. You can see all the builds. Yeah, you can say like if you wanted to kickstart a build, you could actually do it from here. Like if you wanted to do something on demand, you can do it from here rather than go to a command line and do something. But we have removed that obstacle from you, so as you commit something to a git repository, it just automatically pushes in here. You'd be able to see the builds, you'd be able to see the deployments, rollbacks, and all that. So let me show you the rollback capability that I was talking to you before. Um, so if I have all of these builds, um, so as you saw that I have sample 4s, sample 3s, I mean, sorry, I have like build 4s, build 3s, build 2, and build 1. So if I wanted to roll back, all I can do is, there's no like UI for this yet, but then if I wanted to do a rollback, um, I could just do OC rollback PHP sample build 3, and that rolls me back to the previous version. So you would remove all of those things that we just saw. Sorry. Uh, Okay, so I just did the sig rollback, and it says the build 5 is rollback to the build 3. So if I go back to my console and see, I should actually have a build 5 that's been scheduled and run. So it says it's build 5. As you can see, it did not actually do it. It just basically like rolled back the whole change. So build 4 was a change that I did, and build 5 is the rollback version of it. So the rollback will take me back to the previous version. So now if I go back to my window, I should actually see the one without the demo text that I had. So if you say it's still pulling it, so I have 10.1.127 and 10.1.128. So if I go to localhost 9998 where it was running, I actually see hello hello world from Silex, not the updated one. So if I wanted to roll back to the other one, so I can say it's build 4, and if I do a build 4, it actually rolls me back. So the build 6 is basically rolling me back to build 4, which will, so again if I look at it, it is uh, should come up. So this is the build 5. This should just get through. Yep. Yep. So that's build 6. Build 6 should just now roll me back to build 3, which is the one with the demo text. It's pulling one port, it's pulling second one. Right, that's good. So now if I do this one, I should Huh. I don't know why I didn't roll back that. Sorry, I should have rolled it back to build 4, which I did. So yeah, it was probably cached. So that's the one that I just had. So this is the demo world text that we created in the fourth build. So as you can see, a rollback is a very simple operation. You can actually do things like you can create another build. You can just like deploy it just manually instead of like making a commit happening and then pushing it over. So all of this thing is available through the command line right now. That is like activity happening in the, I mean, like OpenShift world, and the integration that we are doing that will take that code, and we have a fork of it which basically does all these changes like connecting to a Teamforge instance and showing everything from the instance rather than through the command line. So thank you for watching. That concludes the presentation.